Okay, so your last set of homework problems is from 47 to 50, and it all goes with the word problem at the top that says Timmy is trying to participate in track and football lifting. Timmy's football coach says that every hour of lifting per week gives him an 8% greater chance of making varsity, and every hour in track per week gives him a 5% greater chance of making varsity. Timmy wants at least an 80% chance of making varsity, but Timmy can only spend at most 13 hours on lifting and track. Without even giving these graphs at the bottom, I know they're going to be a system of inequalities because they use words like at least and at most. So I can form the system of inequalities based off of that information. If I look at the graphs, I know they are all whole numbers, so that percentages aren't going to affect me at all. I'm going to pretend like they're not even there when writing my systems of inequalities. Just like your previous problems with systems of equations, the ones with the percents all go together in the same inequality, and then hours all go together too. So they tell you X is the hours of lifting. So we have an 8% chance, greater chance with lifting, plus a 5% greater chance with track, and it can be at least, so greater than or equal to 80. My second equation is saying at most 13 hours of lifting and track. So I just can say x plus y is at most, so less than or equal to 13. The next thing I want to do is change them to be in slope-intercept form, so y equals mx plus b. So if I take my first equation, 8x plus 5y greater than or equal to 80, I can subtract the 8x to the other side. 5y is greater than or equal to negative 8x plus 80. Divide both sides by 5. Y is greater than or equal to negative 8/5 x plus 16. And my second equation will be x plus y less than or equal to 13. Subtract x to both sides. Y is less than or equal to negative x plus 13. So I am going to write them on the sides here. Y is greater than or equal to negative 8/5 x plus 16, and y is less than or equal to negative x plus 13. My two y-intercepts are 16 and 13, and they are both negative slopes, so all four of these have negative slopes, so I can't cancel them, and they actually all four have 13 and 16 as their y-intercepts, so again, I can't cancel. However, I do remember how to shade to figure out which shading is the correct one out of all four of these graphs. I plug in a point. We always choose 0, 0 unless it falls on the line. 0 is less than or equal to negative 8/5 times 0 plus 16. So therefore 0 is less than or greater than or equal to 16. 0 is not greater than or equal to 16. So let's look at that line in the shading. I'm just going to use A. If A is the answer, we'll circle that. If not, I'm going to pick one of the other three. Here's my line that has 16 as a y-intercept. Since 0, 0 is not on the point, on that shading, I shade the opposite direction. So I shade to the right of that line. So I automatically know right from there A is not the answer. Now let's put 0, 0 in for the second inequality. And negative 0 does not exist. It's just 0 plus 13. Is 0 less than or equal to 13? That is true. So I look at the other line with my y-intercept of 13. And since 0, 0 is here, I shade in this direction of that line. And I notice this area right here is where they both overlap in shading, which is C. For number 48, it says which of the following ordered pairs are in the solution set? Select all that apply. Remember, select all that apply means there's more than one answer. You can plug each of these points in to both of these equations to see which ones are true. Or you can just look at this graph and see which ones have the following points fall in that shaded region. So I can look at 8, 4 first. 5, 6, 7, 8 is right here. And then I go up to 4. 4 falls in that shaded region, so I can circle A as an answer. 10, 4. 10's right here. I go up to 4. That does not fall in the shaded region, so B is not an answer. C, 10, 2, 10 falls in that region, so I can circle it. 2, 12, 2 is all the way over here, 12 is all the way up there. That's not in the shaded region, so I'm not circling. And 6, 5. So 6 up to 5 is right here, which also does not fall in that shaded region. So my only two answers are A and C. 49 says, if Timmy lifts for 8 hours per week, then which of the following hours per week for track meet the goals? Answers are rounded to the whole number. So what I want to do, since 8 hours are per week of lifting, if Timmy lifts for 8 hours per week, then which of the following hours per week for track meet the goals? So since track is my Y, I know I can plug in 8 for my X. So I am going to plug in 8 to both equations. I'm going to use the originals. It's a little easier in the originals. 8 times 8 plus 5y is greater than or equal to 80. And I see a 64 plus 5y greater than or equal to 80. Subtract 64, subtract 64. 5y is greater than or equal to 16. Divide both sides by 5. Y is greater than or equal to about 5.2 when you divide in your calculator. Oh, I'm sorry, 3.2. And then I'm going to plug it into the other equation. 5 plus y is greater than or equal to 13. I'm going to cross that one off because we're plugging in 8 for x. 8 plus y is less than or equal to 13. Subtract 8, subtract 8. Y is less than or equal to 5. So it falls between 3, since it says round to the nearest whole number, to 5 hours per week. Okay, number 50 says, Timmy enjoys track more than lifting. What is the least amount of lifting Timmy needs to complete and still meet his goal? So in the original, they tell us X equals the hours of lifting for football, and Y is the hours per week in track. So he says Timmy enjoys track more than lifting. What's the least amount of lifting Timmy needs to complete and still meet his goal? That's going to rely on our intercept of the two. So technically, the least amount of lifting he can do is 5 hours per week, just based off of the graph. He can't go any less than that, and the most is around here. So the least amount is 5 hours per week.